Hi dosto, namaskar. In the last video we discussed about the structural isomerism. What I told, structural isomerism classified into 6 types. Okay, chain isomerism, positional isomerism, functional isomerism, then chain and ring isomerism, then metamerism, tautomerism. But now we are discussing about the stereo isomerism around the space. This will be this stereoisomerism. Specially, it is classified into 2 types. Okay, what is meant by stereoisomerism? I told chemical compounds having the same chemical formula, but they are different in the arrangement of atoms or group around the space. How it will be? I will show in the example. This is mainly classified into 2 types. One is called as the geometrical isomerism. Another one is the optical isomerism. First we will go for the geometrical isomerism. I will give the example for geometrical isomerism. Geometrical isomerism is nothing but around the doubly bonded carbon. Remember that around the doubly bonded carbon, if the same groups are same site, the same type of groups are similar site, it is called as the cis isomers. The same groups, see methyl methyl, but don't write like this. For the same compounds, sometimes the students what they will be do means similar site means they will be write here one on one carbon only, CH3 double bond H and H, they will write like this. Okay, same side means not like this. Around the doubly bonded carbons means on both the carbon same side means upside or downside. Same side means it is called as the cis. Not like this. This is wrong. Chemical formula is same, but one is cis, another one is the trans. Means around the doubly bonded carbon, the same types of groups are opposite side. For example, you can see this. Opposite or not, around the doubly bonded carbon, the similar type of the groups are the opposite side. It is called as the trans. It is called as the trans. Both they will be having the same chemical formula. How many carbons? See 1, 2, 3, 4. See 1, 2, 3, 4. 4 carbons. It means what? C4. Hydrogens how many? 3 plus 3, 6, 7, 8. H8. Here also you can see 3 plus 3, 6 plus 2, 8, H8. Both will be having the same chemical formula, but around the arrangement of the atom or groups around the space means around these carbons atoms, it will be different. In one case, both the groups are similar side. In another case, the similar type of the groups are opposite side. In one, it's like this. Okay, in one it's like this. If it will be like this, same groups are the similar side, upper side, it is called as the cis. One is like this, one is like this means opposite side means it is called as the trans. Cis, trans, cis, trans. Okay, this is the geometrical isomerism. Okay, now the geometrical isomers, not only cis and trans, we can, this is the butene. Okay, don't forget the name of this compound. It is the butene, 2-butene. Now I will give another example. Geometrical isomers also called as the Z isomers. Z is nothing but Jessamine. Re isomers is called as the antagons. How it will be? I will show. I will give the example for this. In case of cis and trans, what I told, same type of groups means both will be the methyl only. Here also methyl, here also methyl. But in this case, similar types of groups are there. around the double bonded carbon? No, because this is different, this is different. See, this is different, this is different. At that time, it is called as the Z. That is the Jusamen, Z type of geometrical isomer, and this is called as the antagon. That is the antagon. It's nothing but the E type of isomer. Z type of isomer, E type of isomer. When we are considering this means, in this case, when the groups, whatever the atoms or groups are different, but the priority we are considering here, priority means higher priority one. Just see in this case, which one having the more priority? Priority it is based on the atomic number. For this 17, for this carbon 6, this hydrogen is 1. Which one will be having the more priority in this 4? This methyl as well as the chlorine. Same priority means not the same, higher priority group. What it is called? Higher priority groups. Higher priority groups are same side. It is called as the Jusamen. In this case, higher priority groups, opposite side. Higher priority groups, opposite side. Opposite side. That's why it is called as the antagon. I hope you might be understood what is mean by cis and what is mean by trans and what is mean by the Z, what is mean by the E. The students generally what they will be think means that is the Jusamens and cis. Both are same. No, both are not same. Concept is same, but there we are taking the same type of groups. Cis means what we took here? Similar type of the groups, but here similar groups are there. This is called as the cis. This is called as the Z, because here we are considering the priority. Groups are not same. This is the methyl, this is the chloro. It is not same, but both they are the higher priority when compared to these two hydrogens around the doubly bonded carbon. Higher priority, same side. It is called as the Z. Z is nothing but the Jusamen. Okay. Antagon is nothing but higher priority or opposite side. Trans means what? In that case, we took the example like this. Same type of groups, similar types of groups are opposite side in this case. See here, similar type of the groups opposite side. Here we are considering the priority based on the atomic number. Carbon 6, chlorine 17, but here hydrogens is the 1. That's why it is called as the antagon. This is called as the trans. Trans is means similar groups, same type of the groups. Okay, this is about the geometrical isomerism. Then we can go for the optical isomerism, second one. Here the mirror is there. Just see in the mirror. Image how it will be look like. This is called as the chiral carbon. Chiral carbon means what? Center of the atom, center of the carbon attached with 4 different groups. 4 different groups. Okay. Then what we are studying here? Optical isomerism. Here also having the same formula. See, hydroxy group is there, methyl group is there, hydrogens are there, chlorine is there. Chemical formula is same, but the arrangement will be different. How it will be different? See, hydroxy group, in this case you are observing right side. In this case you are observing left side. One is left side, another one is the right side. It means the rotation of the compound also, okay, it will be different. The optical activity of the compound. When we will be send the plane polarized light from here, it will be moving. either right side, either left side. How it will be? Based on the priority, that also. Which one will be having the more atomic number? Chlorine, more prior. Next what? Oxygen, next priority. Carbon third. Fourth least prior is the hydrogen. Then we have to draw the arrow mark from 1, 2, 3, 4. This is anti-clockwise. Anti-clockwise means it is called as the S configuration. S isomer it is called. Okay. Then in this case you can see 1, 2, 3, 4. Priority what basis we are giving? Based on the atomic number. It is rotating clockwise. Clockwise means it is called as the rectus R form. This is called as the sinister S form. One is rotating to the left side, another one is rotating to the right side. It means both are optically active. That's why they will be called as the optical isomers. But in this case, what we have to be remember, molecular formula, chemical formulas is same. But when we will be send the plane polarized light, one is rotating to the left side, another one is rotating to the right side. One is anti-clockwise, another one is the clockwise. Means rotation will be different. That's why they will be called as the optical isomers. These are also called as the enantiomers. Enantiomers means they are mirror images. See hydroxy group matching with this. Methyl matching upper side. Chlorine downside matching. Hydrogen away either side. Both will be look like this mirror images like your two hands. See here, it will be look like two hands. Mirror images are not two hands. They are mirror images when you will be see under the mirror. But they are non-superimposable. Non-superimposable means when you will be keep one hand on the another hand. See, little finger, thumb. Here little finger, thumb. It is matching? Not matching. This way it is called as the non-superimposable. Because thumb it is not going to be matched with the little finger. Okay. This is non-superimposable, but they are mirror images. That's why what they are called? They are also called as the enantiomers. They are the optical isomers. You might be understood the stereoisomerism. Same chemical formula, but arrangement of the atoms or groups is different. See, in this case, right side hydroxy group. In this case, left side. Arrangement only different. That's why they will be called as the optical isomers. What they are called? Optical isomers. This is about the isomerism. Isomerism basically two types. One is the structural isomerism, another one is the stereoisomerism. Structural isomerism, 6 types. Already I told. Chain isomerism, then positional isomerism, functional isomerism, then ring chain isomerism, metamerism, then tautomerism. That is the keto-enol tautomerism. That is the structural isomerism. Stereoisomerism, 2 types. One is the geometrical. Geometrical, another 2 types, cis and trans, and Z and E. Cis and trans, same type of groups. Z and E, same priority group, means higher priority groups. That I given the example. Optical isomers means around the chiral compound, center of the atom, 4 groups are the different. But one is rotating to the anti-clockwise, means another one rotating to the clockwise. Because what is the difference here? Both they will be having the same chemical formula. Only the when we will be send the light, plane polarized light, one is rotating left side, another one is rotating right side based on the priority of the groups. Okay, that's why it is called as the optical isomerism.